In this video, we're going to go over a non-parametric procedure that is analogous to the independent samples t-test, and that's called the Mann-Whitney U-test. And this is a statistical procedure we would use if we want to compare two independent samples. Now, why would we use this over an independent samples t-test? Is because if we have relatively small sample sizes, and so in this hypothetical study here, what we're doing is we are measuring reaction time to two different symbols on a computer screen. And so one group of 5 volunteers sat in front of a computer screen, and their reaction time was measured when they saw a red symbol appear on that computer screen. A different group of 5 individuals sat in front of a computer screen and reacted to a black signal symbol that was flashed in front of them. And so the first step here is to assign ranks to these scores. And so here we have the raw data, the actual outcome variable, the dependent variable measured in milliseconds for the 5 individuals in the red group and the 5 different individuals in the black group. And so once again, here we have relatively small sample sizes, and the variability in the data for each group might be so high that it could very likely violate some of the assumptions with parametric testing with the use of the t-test. And so the Mann-Whitney test allows us to examine the same thing, but not directly on the raw data. And so the first step is to rank the scores from lowest to highest, not within each group separately, but overall. And so here we see the fastest reaction time was 480 milliseconds. That's the lowest score of all 10 scores that we have. So that would be number 1. The next fastest is 540 milliseconds, so it's the next largest number. That's a rank number 2. And we see that the largest number, the slowest reaction time, is rank number 10. So once we have those ranks complete, then we would just add vertically of each column, and we come up with a sum of the ranks for the first group. We'll just label this as R1 is 17. We just add these numbers, and we do the same thing with the second group, and we're just going to label the black group here R2 and to get a value of 38. And so once we compute the sum of the ranks, the next step is to compute 2 scores of the Mann-Whitney U-test using the equations below here. And so we calculate U1, and this is related to the first group, and then we calculate U2, which is the second group, and these are the test statistics for this particular type of test. And we just simply take the sample size of the first group, which was 5, sample size of the second group, which is 5, and we just do the math here, and we have the first group 5 times 5 plus 1, which is 6, divided by 2. We add that to the product of the two groups, which would be 25, and we subtract the sum of the ranks from the bottom right-hand column of the table on slide number 23. So that is the test statistic for the first group. We calculate the test statistic for the second group, and as you can see here, it's very similar. Make note of the fact that the second term uses the sample size in the second group. It just happens to be the same as the sample size in the first group, but in case you have a study where you might have a sample size of 6 or 7 or maybe even 4 in that second group. So you would use those appropriate numbers for the second test statistic, and you subtract the sum of the ranks, which would be 38 in this U2. In the U1, this value would be 17. So once we complete the math, we find that our U1 value is 23, and our U2 value is 2.0. So once we compute that, we move on to the next step where we determine we've already determined the Mann-Whitney U obtained. This is a two-tailed test, so we would have to interpret the data following the completion of the statistics. So once we have those two U values, we select the lower value from slide 24, which was a 2.0. So this is the test statistic. It's whichever one is the lower value is the one we take and we move forward. And as we've seen consistently with the other statistical tests, we compare this to the critical U value from what's called the Mann-Whitney U table. And this is an excerpt from the Mann-Whitney U table. And so once again, this is two-tailed testing, and unless stated otherwise, we go with an alpha level of 0.05, and we have our N1 and our N2 along the column, so the sample size for our first group and the sample size for our second group. And in this particular study, the sample sizes are equal, so it's going to be 5 and 5. And at the 0.05 level, we have a critical U value of 2.0. So the next step is once we have the critical U value from the table. Once again, that's as we saw with the other statistical tests, that's based on research design and not the observed data. The U obtained is based upon the observed data. And the U obtained, if the U obtained is less than or equal to the critical value, and so we're going in the opposite direction here that we saw with many of our statistical procedures, in that if the calculated test statistic was greater than the critical value, we would reject the null hypothesis. For the Mann-Whitney U test, it goes in the opposite direction. If the U obtained is less than or equal to the critical value, we would then conclude that the result is statistically significant, rejecting the null hypothesis that there's no difference between those two groups. So if the smaller the U obtained value, the more likely that the null hypothesis is false. And so in our study, we found that the smaller of the two U statistics, which was 2.0, was equal to the critical value. So once again, it doesn't have to be just less than. If it's equal to or less than, then it is statistically significant. So what we would conclude in this study is that the samples of the reaction times represent different populations, or generally in a very general sort of sense here. But because the computer symbol color, red versus black, was the central question, we would conclude that people react significantly faster to a red stimulus than a black stimulus. The term significantly suggests that this is at the statistical 0.05 level. So this ends this video on the Mann-Whitney U test.